Today I'm going to show a bit of the progress I've made on the graphics and animation side of things. So you see now as the game runs that the players, instead of being squares or cubes like they were before, are now skeletons, stick figures. They're running around, and the frisbee is also, instead of just being a square, it's an actual model of frisbee. I can zoom in, and it's not shaded or anything, so it just kind of looks like a white blob, but trust me for now that it is kind of in the shape of a disc. You can also see as the player catches it, they kind of hold the disc as they run to a stop. And I can show that off a bit even by rewinding. And you can see them catching and then running a bit with it. So I do want to show a bit how this is made because it's pretty interesting. And even though it's a video game, it's the same process basically that you would use when making a 3D movie, like Pixar would do this, or any commercial that uses 3D animation or things like that. So I have here a 3D modeling program. This is called Blender, which is free and open source. And what I'm showing you right now is the player model I have, and this is the same model that I use for the last game. And I'm using the same animation as well from the last game, at least for right now. I might improve those things a bit. Anyway, here's the model. So it's also called a 3D mesh, and it's made up of all these points, and those are also called vertices. And you can see I can select one of the vertices and then move it around, and the mesh sort of deforms to always stay connected to that point even as it moves around. Or I can select many points and then do the same thing. And the points are combined into faces. So 3 points will make a triangle or a face, also called a polygon. And I can do the same thing. I can select the face and then move that around. So it would be really tedious and error prone if I animated the model itself. In other words, if I wanted to make some kind of running animation, if I took every one of these points and moved it around to some new running animation. Because maybe I take the foot points or something, and then I'll avoid hitting the other foot. Maybe I take the foot points or something, and I move them around, and then the model doesn't quite end up looking the way it did before. That'd be really error prone, and also again very annoying. So instead of doing that, we make what's called a skeleton or a set of bones, or Blender calls it an armature. But basically it looks like this. So here are the bones, and you can see it looks roughly like a person again, but instead of representing the person itself, it represents just the bones of the skeleton. So these bones here I can move around, I can pose in different ways, and that's what I'm going to do when I actually make the animation. So I have some animations already loaded. So here's a running animation. And these animations I actually made by videotaping myself, or most of these animations I did. So I videotaped myself, and then I basically traced in the skeleton from the video. So here's running, and this will be a backhand throw. So you see it steps over, and then pivots, and then throws. And this will be the forehand. And there's some other ones in there too, of course, jumping and laying out, etc. So once you have all these animations, and you have the skeleton, and then for each frame of the animation you say where the bones go, you can attach all the points in the model to bones in the skeleton. So you can say that all of the you can say that all the arm vertices are attached to say that all the right arm vertices are attached to the right arm bone. And then once you do that, then as you animate the skeleton, then the model will animate as well. So here's the running animation, here's the forehand and the backhand, etc. Okay. So when I bring this into my game, I basically need to bring in well, three things. I need to bring in one, the actual model itself, which as you can see in my game I haven't done yet. I need to bring in the animation, which is for each of the bones to say how they're oriented for a given frame of animation. And then I also need to bring in the information that tells how the points on the model are connected to the bones. So right now in the game, I don't have the model, I only have the skeleton itself, so it's just drawn out each of the joints on there. But eventually I'll bring in the model and animate that. And just to show you, this is the actual animation data that I exported from Blender. And it looks kind of complicated, but it's actually not too bad. It's just a tree of these bones, and each one of them has a name, either spine 1 or spine 2 or neck or head, etc. And then for each one, it gives a triplet of 3 numbers. The first number is the offset in the X direction from the previous bone. The second one is offset in the Y direction. The third one is offset in the Z direction. And that's basically all it is for the tree, for the actual skeleton tree. And then for the animation, so we say this is a run animation. After the definition of the tree of bones, it gives you all the frames of animation, and this looks insanely complicated, but again, it's just some numbers that represent how the bones are moved. So this animation says there are 17 frames, and then each frame is one line in the file. And each line is basically all the rotation values for the joints in pairs of 3 like before. So here is a pair of 3 numbers. I don't know which joint this represents, it's just in order from the top, but this might be one of the spine joints, and says that, okay, there's a rotation of 24 degrees about the x-axis and 0 degrees about the y-axis and 0 degrees about the z-axis for that frame of animation. And then in the second frame of animation of the run, now there's 24 degrees around the x and 0.6 degrees around the y and 0.9 degrees around the z. So what that corresponds to is basically this, I forget which joint I said, but if it's, say, this spine or this neck joint or whatever, it's that rotation around that axis that caused it to move. And then when you add all those together, then you get the pose of the animation, and then if you step through them one after another, then you get the full run. Okay, I think that's about it. And hopefully soon I'll be able to load the model in and then move the model according to the bones, just like Blender does, but have it happen in my game. Okay, see you later.